So we started this institution to help all the young aspirants to be part of semiconductor journey. Semiconductor is playing a very key role and it's growing very rapidly. As technology is a bone, the key bone for uh, any innovation that you're seeing and usage, the automation in mobile phones, laptops, electronic gadgets, home automation, and automobile industry, the vehicles that you're seeing with all smart gadgets equipped in medical, aerospace, military, everywhere we are seeing technology and semiconductor is part of the innovation which helps in designing the ICs. Okay, so we wanted to uh, bring up all the young aspirants and interested candidates who are uh, passionate about entering into semiconductor. So, as Success Bridge, we have founded it, uh, and we are expanding, and we have started with industry experts. I'm also part of that. Okay, I have a decade of experience in the industry, and our co-founder Yusuf has a decade of managing experience in terms of the organization and the market and the placements that we are seeing now. So we offer VLSI training services and placements, and we do internships. Uh, we take up internship courses also for the academic students. Okay. So our vision is to be recognized a leader in the industry and provide the knowledge, skills, and the confidence. And we are trying our best to empower the individuals and transform them into an experienced and skillful engineers, and eventually help in change the world uh, by having all the young aspirants. And we are providing the high quality, user friendly training services uh, by means that we are providing one-to-one focus and having less number of candidates part of the training session. So we have more focus on each candidate, and we have industry experts who are working in the real-time industry as a semiconductor engineer in terms of physical design, DFT, RTL design engineer, or a design verification engineer. So we are requesting them and making them part of our team, Success Bridge team, and using them as trainers. We're trying to train all the young aspirants, and we want to provide an efficient way of learning and training using our EDA tools, which are the real-time tools that we are using. We are using Synopsys EDA tools. So let's go into that. So our trainings are design verification, design for test, physical design, and analog layout. So these are the 4 courses that we provide at the moment. So as you can see in design verification, we have the basics of digital system design, introduction to VHDL, HDL, or Verilog programming, and the advanced Verilog concepts we teach. Okay, so likewise, we have a set of course content for each working domain. In DFT as well, we start with the DFT basics, and we have a AT, the automatic test equipment. End of the day, each IC has to go through this cycle. So we are going to discuss on that, and we have full ASIC flow DFT. So we have a real-time course structure for each and every domain with the real-time tools working on the real-time designs. Similarly, on the physical design part, anyway, our trainer is going to explain you about this today. So it will be an introduction to physical design, and we provide synthesis and static timing analysis, floor plan, power plan, placement, CTS, routing. Okay. So likewise, we have all the courses uh, nicely drafted as per the real-time requirement of the companies. So you can learn here and get placed easily. So our soft skills are part of a complementary where we provide uh, proper communication skill development and personality development, and you will have assignments where you can work on presentation skills and will be monitored and guided. And when you try to share your learnings among the team, you will have public speaking and email writing and etiquette and interview skills, and we will do a lot of interviews and mock interviews. Okay. And the selection process is that you can apply on website, and we will review your application and then be admitted. We'll have limited seats for each uh, course. So based on that, we'll proceed with this job oriented training. So our specifications in times of training, we use industry experts coming from the industry, working in the industry, and there will be the trainers, and we use industry standard EDA tools. So we are equipped with the tools that we use in real time IC design. So we are also using the same real time projects. We provide tool access to each and every individual who has registered and working as a trainer, as a trainee, and we'll give module wise assignments after each module, and we provide this soft skills and communication sessions, and we have max 15 to 20. 15 is online and 20 is offline students per batch, and we do conduct mock interviews from industry experts outside of the success bridge, like within our influence and circle, we bring in the industry experts who are working in the industry. They will perform your mock interviews after your training. So individual focus is very much our key points. So we do this individual focus, and we provide flexible timings, and we provide recording sessions of each and every training online sessions. Okay. And we have the lowest and affordable fee structure in the market currently. If you take any course like verification, DFT, physical design, we are having the lowest uh, fee structure and affordable for everyone. And as you can see, we have a 100% placement support until you get placed. As long as you are willing to learn, excel, and prove yourself, okay, it is very helpful for you as well as for us to support you in the 100% placement. So as you can see, we have our website successbiz.co.in, and where you can go and see uh, our website, about our profile and our partners, placement partners and EDA partners, everything. So let me just show you a bit of glance. So this is successbridge.co.in. .co.in is our website, and you can go through our website to learn and understand what are the courses that we provide. You can register here for any available courses. We do provide some no cost EMI options for the underprivileged, so you can check for the loan eligibility. Okay. And the previous one, those who have got trained and settled, got placed by us, uh, the testimonials you can see that. Okay. So on a searching part, how do you search a success bridge? You can search for success bridge in a Google. You'll get to know success bridge training institute. Okay. So it is located at Kormangla, Bangalore, Karnataka, 560034, India. Okay. Right. Moving on. I don't want to waste much of your time and hand over to the trainer. Before that, any questions and queries you have, we will discuss after our technical presentation by our trainer, physical design trainer. Okay. And you can always post your questions in the chat window. So even that will be addressed end of the session. Thank you. So do we have the trainer here?
Yeah, hi Kumar.
Yeah, hi. Yeah, Harshit, please go ahead. Thank you.
Yeah, thank you. Hi guys, good morning. I'm Arushi. I'm working as a physical design engineer in one of the product company, and I'm having a 8+ years of experience currently working as a physical design engineer domain. So today I welcome you all for the physical design demo. So I don't want to waste your time. So quickly we'll go to the physical design introduction. So let's start like career opportunities, which is in the VLSI. So here we'll see the concepts, careers, and what are the courses, and we'll see the what are the insights and what you will get the guidance about the VLSI. So today's demo agenda we'll see why VLSI, and then if you know why VLSI, so after that we you should know about the introduction to the VLSI. After that, sorry. Sorry, I forgot to share my screen. So in the agenda, we'll see about the why VLSI, introduction to VLSI, introduction to the physical design, and after that we'll see that what are the opportunities you will get in the physical design and how the industry is going in the current market, and also you will get the how the semiconductor industry it will be in the future, and later we'll discuss take the like question and answers. So if you take why VLSI, if you see the graph like before going to like a 20 to 30 years how the market was, it was having a huge like a 10-20 billion dollar. Like in our academics we have seen about the transistors, how the transistor it will be in the vacuum, right, vacuum cleaner, it how much that was big it is. And if you see that and we have heard about the Moore's law, like about the transistors, and whenever we heard about that it will be like a go strange out of that, right? Whenever you see the market before it was like a huge, whatever you take the electronics instruments it was too costly. Nowadays you are getting in a thousands rupees, like a 500,000 rupees also you are getting. Why? Because how much the market has like seen the growth itself in the market. So here you can see that in if you speak just like a 87 to 2020 how the market has grown, and now also how the market is booming in the industry. Why it is so, why it is booming? If you see the earlier days how was it is like take any electronic instruments, the size were very huge, and if the size were very huge it requires the more power, and the whatever the heat you are getting the dissipated it is so much, and also it is not so much of reliable. Just let's take an example like TV. Okay, if you have seen in your childhood you have seen the TV, it's like a dome shape, right? So whatever the if it was that much huge it requires one big table, and inside that if you just see in the TV there were lot many like components were introduced, and that size is also more. If those components were more size of those components more, it requires more power. So whenever the or any electronic instruments, it is taking the more power, obviously it will dissipate and heat. In like we have inserted so many so much of components, right? All the components which will consume the power and it will dissipate the heat. So that's why we have like sometimes if you just kept on the like hand in on your TV, sometimes you may like you can sense that heat, right? I think some of you guys, like you guys did it in your childhood. So whenever it comes to the portable, it is not so much of reliable. Then after the like whenever the VLSI got advanced, just it will be like very compact. When nowadays you can see that all the components were electronic components were very compact, and it will be the speed when compared to it will be the faster, and for the portable purpose it is very easy. And the cost wise also you have seen like before you have heard about the TVs like LCD LED TV, all the TVs whatever you are getting, it will be like 40 50,000. Now you are getting in 10,000 20,000 also you guys are getting the TV which will be hanged on your wall. It won't require any separate space for the TV. Why? Because the size got compact. Since the size got compact, whatever the we have introduced, whatever we have used the components which is inside the TV, all those are getting compacted. So you need the less power, less space, and for the portable also it is very easy. Like when you compare the speed wise also, the speed wise will be more, because nowadays we are talking the frequency in terms of gigahertz. 900 megahertz, 1 gigahertz, 1.2 gigahertz. When you see like heard about the before, it was like 100, 200, right? So the speed also got more nowadays. And when compared to reliability, since it is uh, size wise, speed wise, cost wise, power dissipation wise, when compared to the earlier days, nowadays it is very easy. So it will be the reliability. So that's why we used to change everything, and the space whatever it is requiring, it is also less compact. So next, if you have seen here, this is just a 5 MB. The IBM was used to shipped in a 1956. You guys can see that here just a 500 MB hard drive. It is so complex to ship the 5 MB hard drive. This was complicated in 1956 whenever you want to store the data and send it to somebody, right? So this was this much you can see that how many people are required and what is the cost of it and what is the size of the 5 MB hard drive. So when you use the VLSI advancement got introduced, so you guys can see that here in a single CD, and you guys can insert the GB of the data inside the CD. And more advancement, take the pen drive. In the pen drive also you are getting the 16 GB, 32 GB, right? You guys can save your data, and it is for the portable purpose to carry the data, it is very easier, and the cost wise also it will be reduced. If you see that in this picture, right, whatever we have seen, the 5 MB hard drive, it requires $1 billion just to ship the hard drive. But nowadays we are carrying with a pen drive with a like 64 GB data. Hardly we require how much? For the pen drive we need like a thousand, in 1000 2000 you will get the pen drive. So you can easily, for the shipment, it is a zero cost. That much VLSI is helped for us in our day-to-day life. So then we'll see that whatever we talk, the VLSI, then what is VLSI? The VLSI is nothing but it's a very large scale integration which is within the IC, whatever we are doing in the chip, right? So inside that we are doing it. So in the VLSI, we do have like a small scale integration, medium scale integration, large scale, integration and the very large scale integration, and then it comes to the ultra large scale integration. When we are seeing the small scale integration, it is nothing but we were using the transistors between the 10 to 100 as compared to the industry, right? Suppose we'll see, we heard about the small scale industry, large scale industry, medium scale industry, right? The same thing here also. When the transistors being used between like a 10 to 100, whenever we were using like a 10 to 100, it was a small scale integration. But when we were using that, right, the speed voice, it was not that much of reliable. So that's why they went to the medium scale integration. There we were used about like around 1,000 number of transistors. So that was not so much of reliable. So then they have gone to the large scale. There they have seen like they have used the transistors between the 1,000 to 10,000 transistors. But compared to that one also, it was not that much of used. So then they have gone through the very large scale integration. It means that they have used the more than 10,000 of transistors. So whatever we have using in the current era, we are using the millions of instances inside our single block, not the chip, inside the block. Nothing but millions of transistors we are using in the chip. So that's why it is very large scale integration. There is a ultra large scale integration also, but it was not that much of popular, so the people didn't use the ultra large scale integration. The very large scale introduction, whatever the VLSI we are using, it was giving that much of reliability, so the people are continued with the VLSI itself. So the VLSI is nothing but it will integrate all your transistors integrated in a single chip, which will be for the functionable. So in the ICs, nothing but integration chips. So here we have the three categories. One will be the ASIC, FPGA, and microprocessor. Whatever we are seeing the physical design, right, it will come under the ASIC. So in the ASIC, we have like a fixed circuit which will be fabricated in the silicon wafer. So the ASIC will require a less power consumption, and in the single silicon wafer, you can integrate the multiple ICs. So it will be cheap on the high volume because in the single wafer we'll fabricated 1,000 ICs. So that's why it compared to the others, it will be on the cheaper side and the high volume. And the when compared to the size will be very small, and the speed will be the more, nothing but compared to it will be the faster. To go to go through the ASIC, you require some knowledge on the VHDL, Verilog, C++, and the digital. If you have the just knowledge on these things, right, it will be helpful to go through the ASIC flow. Next will be the FPGA. The FPGA is nothing but the field programmable gate array. So these circuits will be flexible, and it is also fabricated on the silicon wafer. But it requires a high power. Why? Because the size of the FPGA will be more. So that's why it consumes the more power, and it will be cheap on the low volume, and also it fast takes more to implement. For the implementation purpose, it will be the faster. To go through the FPGA, you guys need the knowledge on the Verilog, VHDL, C++, and also digital circuit, and also you guys need the some of the applications on the FPGA, because you guys need to develop, right? So that's why you guys need all these like skills. Microprocessor, I think you guys are familiar about the microprocessor. Why? Because in our academics you guys heard about the microprocessor, and sometimes you have written some programs for the microprocessor, and I hope you guys did the lab on the microprocessor also. So whatever the circuits which will be on the microprocessor, it will be also the flexible, and it is also fabricated on the silicon wafer, but it will be the programmable, and it consumes the more power, and compared to this, it will be the slow compared to the ASIC and the FPGA, right? It will be the slow, and it will be easy, cheap, and it is a very easy to use. We did some programs in our academics, right? And also we have executed it, so it is easy to use. The knowledge you need for the microprocessor is C++. For the programs, right? So you guys have a knowledge, should have a knowledge on the C and the C++. You guys see, this is a chip. What you guys see, that whatever these are the, right, these are all are the pins, and this is a IC. Whatever you guys, this is a whole is a IC chip. So here, whatever these aluminum, right, these all are the pins you guys can see here. For the picture wise, it is showing like a bigger, but when you see in your eyes, right, through, it will be like a just like a dot. It will be very small. So here, like, next, how the VLSI has come into the ground. Like when you see, like, just like 15 to 20 years back, right? So they were, the people were using about the 180 nanometer, 90 nanometer. When after that it got advanced to 65, then it came to 45, 32, 22, 14, 10, 7 nanometer technology. The NM is nothing but the nanometer technology. So you guys have heard about the Moore's law, right? Every 18 months the transistor get doubled. So when the transistor will get doubled, the technology, whatever the nanometer we are using, it will be got reduced. Nothing but here, whatever we are seeing, right? 130, 180, 90, 65, 45, 32, 22, 14, 10, 7. In present also we are working on the 3 nanometer and the 2 nanometer. Some of the companies are trying for the 2 nanometer and the 1 nanometer also. Want to try. So this is nothing but how the market is getting advanced. The VLSI is getting advanced. Before we were using the CMOS, then comes to FinFET. Before we were using the MOSFET, now we are using the FinFET. How much the whatever the technology has grown. The nanometer is nothing but your technology node. So then what is that nanometer? Like how they will decide how the market is performing that. The nanometer is what is a technology node? Nothing but how it is getting compacting, nothing but this is the gate length and the width of the gate. Nothing but they will reduce the length and the width of the gate. Nothing but whenever your gate will get compact, your technology node will get advanced. So whenever it is advanced, it will have some challenges. So you will learn the things. Nothing but the whatever the transistor get like compact, and your electronic in whatever the component you are using for the IC, it will get compact. The nanometer is nothing but it is the W by L ratio. Nothing but the width of the gate and the length of the gate, which is getting reduced. After that the technology, so that's why whenever you will reduce, right, so the technology node get advanced. The nanometer is nothing but your technology node. So next, whatever we have seen, it is the introduction about the VLSI. Now come to the physical design, how the physical design will be. So how the, before going to the physical design, how the physical design will come into the picture and why you need the physical design. So whenever you have the, some customer will come and they will come requirements, right? So they will get the concepts, and that concept will go to the RTL design team. So they will just write a code for that, whatever the design is. So after that, the verification people will do the test, will write the test cases, and they will do the verify that design. After that, it will go to the synthesis team. They will generate the netlist, and that will come to the physical implementation team. Nothing but the physical design. After that, it will go to the sign off team. There, they will go for the timing checks and some DRC checks, which is given by the fabrication team. So after that, once it is done, it will go for the tape out, nothing but the fabrication process. After the fabrication, that you will get the devices. After that, it will be the going for the testing purpose. So now whatever we have seen, that is the same thing. Like you will get the specification. After that, it will go for the design and the verification. Next, it will go for the RTL synthesis. And next, you will partition the chip. It will go for the DFT for the further tests. So after that, it will come to the PD team. The PD team, what the PD guys will do, they have to do the floor planning, placement, CTS, routing, final verification, and then it will go to the GDS2. So here you say you have seen about the floor planning, placement, CTS, routing, right? It is similar to like the physical design is nothing but the physical implementation. How you are constructing a home, similarly, we have to construct the chip. So this is how whatever the cells will be there, right? This is just a one NAND gate. Here you can see that this is a NAND gate. This is a CMOS structure layout, and this we have to insert inside the block. Here you can see that, suppose consider that this is the chip. Inside the chip you have to place all the cells. For example, this is having a one NAND gate. Similarly, you have the multiple instances that you have to place inside the this chip. That's what the physical design engineer will do. Next, we'll come to the physical design flow. How the physical design will come. So whenever you want to start the physical design, you need some inputs. Suppose consider that you want to construct a home, you need the some inputs, right? Like you need the site, you need the uh, uh, people to work, and you need the some bricks, cement, everything. The same way, to start the physical design, you need some of the input files. That is nothing but like a STC file, UPF file, ScanDef, diff, lab, technology files. So you need some inputs, and then you have to do the floor plan. The floor planning is nothing but in the chip, inside the chip, you have to place all the memories. That's what the floor plan is. Whatever the pins like memories will be there, right? Like a SRAM, DRAM, DDRAM. What kind of memories you will be having, you need to place inside your chip. That's what the floor planning. Suppose consider that you have like a floor planning is nothing but whenever you want to construct a home, you will do the blueprint, right? Here I need the veranda, here I need the hall, here I need the kitchen. The same way, you have to do the floor planning, nothing but here in this I need to place this module, and nothing but here I need to place the this module, nothing but these memories. That's what the floor planning. So after the floor planning, you will be having the power planning. Nothing but if you are constructing a home, for all the rooms and the accessories, you want the power supply, right? So you will do the power planning. Like one electrician will come and they will do. Similarly, here also in the chip, all the memories you want to give the power supply. So by doing the power plan, you will supply the power to all the your memories. After that, it will do the placement. Placement is nothing but you will be having the millions of instances in your design. Nothing but it might be the flip flop, it might be the AND gate, NOR gate, some logics will be there. XOR gate, XNOR gate, all the things you have to do. Here, you don't have to do it manually, the placement. The EDA tools are very smart. They will do by itself. They will do all the placement of the cells logic with respect to those, however you have placed the macros. So it will do the placement itself. After that, it will do the legalization in the optimization. Suppose it like it will be having the row because it needs the power supply, right? So it will the tool will place the proper like standard. It should not be overlapped. Like one, like upon the AND gate, it should not place the XOR gate, right? So that's why it in the optimization place opt, it means that the placement optimization, the tool will do it properly. So after that, we need to check the timing, because you have placed all the cells, right? So we have to check the how the timing is and the congestion is. Congestion is nothing but how much the area is congested. Like suppose consider that like the same meaning, however, in the normal, right? Whatever the cells are placed for the movable purpose and the routing purpose, it should have some space. If suppose in a inside the room there is a space for the 100 people, if you just put a like 1,000 people, it is not so possible to breathe out for all the people, right? In the same way, like whenever you are placing the 100 people, the 100 cells should be there. You should check that it should not be the 1,000 cells the same way. So once the placement is done, we'll check the timing and the congestion. After that, we'll go for the CTS. The CTS is nothing but the clock tree synthesis. So whatever the flops is in your design, the clock has to select the clock has to build for all the flops. Nothing but whenever you have the instances, it will work on the clocks only, right? So the clock has to reach all your flops, nothing but whatever in the designs which you have the cell, for everything the clock will get built. After that, for it will use some techniques and it will do the optimization. Whatever the clock is building, right, the tool only will do that. So after that, it will go for the routing. The routing is nothing but it will do the physical connection for all the cells. Suppose like there is a cell X and the cell Y. Those two are in a connection. So the tool will build the physical connection with the help of the metal. After that, it will do the optimization. After that, we'll go for the some PV checks, timings like DRC, DFM, DP, uh, some other things like LEC, everything we'll do, and then we'll go for the sign off stage. Nothing but after that, we'll go for the timing, and after that, it will be going for the good to go for the tape out stage. Nothing but it will be going for the fabrication. So it will be going after the fabrication, it will go for the testing and the packages. So this is about the PD. If you learned about the PDs, what are the opportunities you will get? To get those opportunities, what are the skills are required? So if you want to go as a design engineer, you can go as a front end engineer, ASIC, FPGA front end, ASIC physical design engineer, analog mix design engineer, library developer, IP developer engineer. If you want to go as a verification engineer, you can go for the front end verification engineer, nothing but the DV, FPGA backend, physical design verification, nothing but your PV, AMS verification, and also you can go for the EDA tool validation engineer, IP verification, board validation engineer. And what are the skills you guys require? Whatever you have seen the opportunities, right? To get those opportunities, what are the skills you require? If you want to go as a physical design and the verification engineer, you should have the experience on the tool. Whenever you will be going for an interview, they will be asking for like how many projects, like how what are the tools you have used and how many projects you have worked, and what are the skills you have around the physical design. So you guys should exposure on the tool, and the you should have a knowledge on the digital circuits and the PD, whatever we have seen, the floor planning, power planning, CTS, placement, PV, right? You should have a knowledge on that. And also you should have a small kind of knowledge on the shell per tickle. any one of the script is okay. Why? Because nowadays for the automation purpose, everything you can't do it on yourself. So by man, instead of by doing a manually, if you know the script, you can go do it in a minute. So that's why scripting knowledge is important. Next, you can see the trends which is in the semiconductor. So these trends Kumar will handle. So I'll hand over this onwards to the Kumar. Thank you guys for your patience.
Thank you, Arishi. Hello, everyone. So we have finished the technical aspects of physical design, what the course content would be, and we can also show what is the actual full course content. Uh, what Arishi explained here is the physical design subdomains that you will be learning. Okay, and as we said, we are going to work on a synopsis EDA tool, which real-time environment uses, and market uses almost 80% of the market uses the synopsis, prime time synopsis, DC shell or fusion compiler, or all the tools related to synopsis. So we have all the real-time tools available. Okay, so why I'm saying more stressing on the tool is, uh, in semiconductor, any working domain that you take, tool takes care of everything. We have a tool for everything. Okay, so we learn the concept as an engineer. Okay, and we have to understand the concept of how to implement, let's say, physical design. How do you perform, how do you convert RTL code of an AND gate or an NAND gate into a physical gate connections. Okay, all that you have to learn, and using the tool, how we are going to perform it. So we use the tool to do everything in physical design or DFT or verification. So we need to understand and learn the tool usage, behavior, and tool commands in the course. So why course is needed is, in the first place, is you cannot directly charge into the companies after your academics and say that I have done my academics in Triple E, ECE, or any other groups related to electronics. You cannot directly ask for placement into semiconductor, because semiconductor uses the tools that are not present in the academics. Now government has implemented semiconductor, uh, uh, industry is growing in India, and EDA tools like Synapse and Mentor Graphics are going to support all the major colleges and universities in the India, in the country. So now the upcoming batches will have a privilege. Those who are learning from a top colleges or universities to learn on the real-time tools. Other than that, you have no exposure on the real-time tool. So you cannot be taken in, and semiconductor does not spend time and effort in training after hiring. So there is no concept of training after hiring in semiconductor. You have to come as a trained fresher. You have to be trained on that particular tool and concept. So that is the main reason any engineer who is interested or passionate about building their career in a semiconductor, they have to learn this particular course in any of the training institutions and get certified, and then clear the interview and get into the companies as a trained fresher. Okay, right? So everybody, I would request, there is a form in the chat window. Please fill in the form so that our team can help you out when you reach them. Okay. As I mentioned before, you can always reach out to Success Bridge through website or Google Maps. You can map. You can find the institution can call to the number. Okay, you can also mail. Okay, using the Success Bridge mail. Now, placements wise, let me just share my screen. So these are the recent placements that happened in July and June and July. I think we have placed these people uh, in DFT and physical design batches that have been finished. Okay, so we have a very good track record of placements, and being industry experts, we have good connections with the companies and trust we have built up working in the industry for a long time. So coming from Success Bridge, you're an easy pick for the companies as long as you're learning and able to explain the concept in the interview. Okay. So there are many companies in semiconductor at the moment. As you can see, even Synopsys hires, Cadence hires. Okay, okay. EDA companies also has the openings for physical design, DFT verification. Similarly, fabless companies like Broadcom, Nvidia, Qualcomm, Apple, AMD, Xilinx, Marvell, MediaTek, all are present within Bangalore, Hyderabad, Pune, Delhi. Okay, majority of them are in Hyderabad and Delhi, Hyderabad and Bangalore. Okay, Samsung, Micron, Intel, all of these companies are hiring extensively, and we have uh, a complete uh, contact with all of the companies existing in the semiconductor within India, and I have connections outside India as well for the experienced people. So we try to support you guys as long as you are learning, and until you get placed, we are going to support you. Okay. So I don't want to bother about the concept. Let's directly look at the packages existing in the semiconductor. So on a fresher, the salaries are starting at a 6 lakhs package for all the domains in the current market. So it's up to the expectations. If you are very skilled up and fast in grasping the concept and able to explain it so vividly that interviewer is so much impressed, he can give up to 12 lakhs also. Okay, so there is no such scale as that. As a fresher, you can get a very good package depending on how good you are performing. Okay, so on a for the first 3 years is how do you enter into semiconductor and build your career, learn the concept. So after 3 years, your salary 3 plus the salary is 16 lakhs to 20 lakhs or 22. And if you gain 5 plus years of experience, the minimum package that you see is nowadays is a 24. It's a minimum package for a 5 plus engineer. Okay, and maximum of 5 plus I have seen, I myself earned it. It's 32 lakhs per annum. Okay, this is the old numbers. And what I'm saying is nowadays the packages are very much high in India, given India is growing a lot. Okay, so for the first 3 years, you have to learn the concept, learn the real time working nature, gain uh, uh, good rapport with the team and managers, and learn the etiquettes. Once you are good, you are confident that I can crack a 3 plus interview or a 5 plus interview, change the job, and you are good to go with a high salary, very high salaries. And if you have 5 plus years of experience, you are eligible to work in any other country outside the countries. They provide visas for 3 plus and above. Okay, so 100% success ratio is for 5 plus, and 3 to 5 it is 50% success ratio, because less companies hire for 3 plus. Mostly 5 plus, you are eligible to work in any other country: Europe, Malaysia, Japan, China, Korea, UK, US, Canada, many. Okay, all countries are hiring because more resources are from India. We lack fabrication units within India. Now we are growing and we have fabrication units now, and we are building a lot more in the coming years. But we are renowned for, India is renowned for resources. We have more engineering outcomes in a year. We have more resources than any other country in the world, in the entire world. So you are a very good candidate, and any other country in the world believes that Indians are hardworking in nature and efficient and skillful. That's what they believe. So aim for it. Aim for 5 plus. Until 5 plus, don't look at where you're working, how you're working. Learn it. Learn the concept. Learn the practical way of working. Okay. Increase your skills. Skill up and done. Okay. So yeah, that's it from my end. Any other questions related to the course or anything? Please unmute yourself and ask me. If you're hesitant, you can text in the chat window. You can type the questions. I will answer. On a technical spree, if you want any questions on a technical side, we have the trainer online, and trainer can answer for you. Okay. So if you do not have any questions, I would like to say that our course is for 4 months, and we take an extra 2 months, like total 6 months, covering the mock interviews and placement support and assistance. So the first 4 months would be your training period, and the 4 months of training period, this batch is going to be an offline batch situated in Bangalore, Koramangala, in the institution. Okay, so this is an offline course, and we already have a huge people already registered. Okay, and we're trying to filter them uh, at the moment, and we have limited seats as well. Okay, so as I said, we are not going to take more than 20 or 25 for offline and 15 per online, because we will lack that one-to-one focus if we are trying to take in more number of candidates in a batch. Okay, so we want to reduce the number of candidates in a batch so that we can focus and try to place them efficiently. Okay, and we also tie with the companies, and based on the company requirements also, we sometimes plan for a batch. So if the companies that we are tied up, if they say that okay, we have 10 openings in the next 6 months, so then we start how many opening based on how many openings in the companies, we start batch accordingly. Okay, we want to be efficient in our ways, so please try to help uh, in trying to register as early as possible. Our offline batch is going to start for physical design on 15th of July. Okay. Yeah. So yes. So those who are BTech or MTech or with gaps, all are eligible for the course. Okay. Let me tell you that for BTech, those who are pursuing BTech, Okay, for them, this course will help in such a way that by end of your academics, by fourth year, you are eligible for placement support. Okay, so you are getting trained by us in your BTech first year, second year, third year, fourth year. By end of the fourth year, we will support you in placement. Let's say you are in fourth year, you are directly eligible for the placement support. Okay, so for the same ways for the MTech. Okay, as long as you are ready and your academic is done, you are eligible for the placement support, and we are going to place you in the companies. And those who have gap, let's say you are 2010 passed out, 12 passed out, 14, 15, 16, 18, any year, you are still eligible. So the one good thing in semiconductor is we are not uh, having more number of what programming languages. We have a same single programming language of Verilog. For few courses, we don't need to learn the Verilog programming as well. Okay, so only RTL design engineer and verification engineer would require a coding experience of Verilog, and we don't have, other than Verilog, we don't have any other programming in IC. And Tickle or any other program scripting languages, you will learn part of the course. Okay, so you don't need to explicitly learn outside. And our scripting is very limited in the sense how much tool requires, how much you need the scripting to program or command the tool. That much only we learn. Not like a software, we don't write thousands of lines. We don't do that. Okay, and everybody is eligible as long as you get trained up, learn the course, and semiconductor needs lot of resources. I see that many academic students coming from ECE triple also go into software. I don't know which is more easier for them in the placements from the college, or easier in any way. I don't know, but people tend to do that, and we have more resources requirement. Okay, that is the reason the pay is very high. So the training cost compared to market, we are giving very less cost. We are taking a very less cost for the training for offline course. Uh, I think after discount price, the current batch we are having, I think 80 plus GST, and for colleges we have a different pay. I mean, academic students we have a different pay structure. Please reach out to us. Okay, our contact number is in the chat window. Please reach out to us. Our team is going to explain you based on your academic profile. So that is the reason we asked you to fill the form. So if you fill the form present in the chart, so when you try to call the customer support to reach our institution, they will take up your data, and based on that, it will be easier for us to guide you. Okay. Right. Any other questions? Yes. Let me post the form again. So, team, can you post the form again for those who have joined now?
Yes, sir, I will post it.
Yes. Right. Any other questions? So general questions, generally in many demo sessions, we plan every month we have a batch. So the major questions they ask are, I'm currently pursuing BTech or MTech, or I am working as a faculty in a college, either a HOD, head of the department, or a professor, assistant professor. So we have many people, we train them and place them. Okay, there is no such thing as you should be a fresh graduate. Okay, so everybody is welcome as long as you learn and you have the background and of electronics, electrical, or any engineering background. Okay.
Hello.
Yes.
May I know what are the clients you have present opening?
At the moment, we have physical design and DFT openings for the companies within our
Yeah.
clients. Yes.
May I know the client names?
Client names are confidential at the moment. We have clients which I cannot reveal because there is a market that we are competing with. So when you can communicate, we can directly have a call with you later after the
Okay.
session. Okay. So
Okay.
we'll be able to happily provide you that. And the general knowledge that we can share is already on the website. What are the uh, tie-ups that we already have officially? And we have many companies, those who are unofficially, we are tied up with. Okay, those who don't want to advertise themselves, like startups or companies who are service-based companies who are performing very well and trying to project to the product-based companies.
Sir, are you providing accommodations to the students who have come from outside? Or if you are not able to do
Yes.
nearby, if you have any accommodations, what will
Yes.
be the approximate cost?
So we help them in the accommodation part, but we don't provide accommodation from Success Bridge. So our institution is located in a Koramangala, Bangalore. So near the institution, there are many uh, what we call uh, the hostels for men and women, which we support them. Okay, we can help the candidate to be taken into the hostels.
How far it is from Majesty Circle, sir?
Uh, Majestic.
That
Yeah,
Majesty Circle.
I'll answer, Ganesh. So Majestic, it will take approximate 9 to 10 kilometers.
Okay.
Okay, as Ganesh told, near to we have many hostels and PGs. The cost will go approximate in between 5 to 6,000, which includes your food and everything
Okay. Thank you. Thank you.
a month. It's like totally walkable distance from our institution.
Oh, hostel to your institution.
Yeah, yeah, it will
Yes.
take less than 5 to 10 minutes walkable distance. Because the institute where our company or institute located is one of the like in prime area, Koramangala, if you can look it out, fourth block.
Okay.
Okay, there are many flexibilities. Flexible feasibilities are available over there. Services you'll get in. If you wanted to go somewhere, you'll have an transportation facility. Everything will be there. Near to walkable distance, we have many software and other IT companies.
Your courses, sir, your courses include the basics, theory part, and then go for practical, or just straight away you will
Yes,
start the.
I would request Ganesh to share the course curriculum once, Ganesh.
Okay. Uh, I think our industry expert, Arashi, can you help share the course content for physical design? I do have DFT in hand, but not the physical design.
2 minutes. I'll share it. I'll share. In the meanwhile, any other questions, you can just take it, Ganesh.
Yeah. Okay. So, yeah, given your question, I understand that uh, our course, any semiconductor course that we provide, digital design concepts are the basics. We go through that for any incoming student like non-EC background, non-core background also are eligible for semiconductor. So it is easier for them to understand the semiconductor basics, digital design. Then we move to semiconductor basics, the tester AT semiconductor basics. Then we move on to the course.
So, what are the timings, sir, every day? What are the timings, classes timings, or for offline course people, are you offering leave Saturday, Sundays? What will be the timing, sir, please?
Yeah, sure.
Because for the people who are outside, if it is possible, can go weekend to their house.
Yes,
That
yes.
way I'm asking.
Yeah, I totally understand. So
அவங்க தான் வந்து தனியா வந்து கேட்க சொல்லி போடுறாங்க.
Thank you for your demo, sir.
Is my screen visible to everyone? Hello, Ganesh? Hello? Ganesh, is my screen visible to everyone?
Yes, sir, it's visible.
Ganesh, you can go ahead, please. Yes, so this is our physical design curriculum. So as us, we'll start with the digital electronics, which is basic requirement, which includes logic gates, Boolean algebras. Okay. See, I don't think none of the institutions will provide these basics. Okay, they directly get into the topics because they basically think it's been already thought with the people who are coming for the training. But based upon the because any VLSI engineer, we feel basically digital logic design is pretty much required. So we'll start with the digital basics, digital electronics. Then module 2, CMOS, which has introduction to MOSFET, CMOS, and module 3 will go the Linux. And each and every module will have, after completion of every module, will have assignments and mock interviews. Okay, so which will give us to ensure you will have a good performance by the end of the training completion. So as told, the scripting part is pretty much required. So we'll take up the TCL, which includes introduction, special variables, data types, and then we'll go to STA. So introduction to STA, programming analysis, types of STA. Okay. Then the physical design. So fluent synthesis, reading flow, building setup, library, DEF, netlist, STD. I would request to all of them to go on mute, please.
சரியா போயிடும்.
Okay, then physical verification, inputs, DRC, LVS, DRC, soft check, so antenna DFM. So these are actually the highlighting points. So, but the course will go much more deeper into the each and every topic of PD, STA, synthesis, PV, and all. And this will, I think if required, I think we have an WhatsApp group. Our individual also we can share across to you if you can reach out to our support team. Any other queries we have?